Hi, I'm Brian Doyle with Miller Welding Automation, and we're standing here on the floor of McCormick Place for the 2011 FabTech AWS show. What we're showing here today is how our robots can adaptively fill a workpiece in a groove weld where perhaps it's impossible to hold the root gap consistent throughout the length of the weld. These kind of grooves are typical with manufacturers that do mining equipment or earth moving equipment or excavators. Anytime you have a long weld, say on a dipper arm or a boom for an excavator, where you'll have either a single bevel or a double bevel groove weld where it's impossible to hold that root gap consistent over the length of a very long weld, and the volume changes. What our robots can do is measure the width of the gap and adaptively adjust to make sure your weld ends up correct. What we have simulated here is a weld on a circular boss. What the robot's going to do is it's going to come down and search and measure in 4 places, and then it'll adaptively change the weaving width to adaptively fill that joint. So I'm going to have the robot continue here. First it goes to a known location and uses touch sensing to set the length of that stick out. Now you're going to see the robot sense. It's going to be looking for that groove. Now it's going to go to quadrant 2 and repeat the procedure. An important element on heavy equipment is the voltage with which that robot is doing the touch sensing. We have high voltage touch sensing available that can have the robot search that joint at 600 volts. 600 volts is enough to touch through most of the mill scales that you typically see on parts like this. It's also sufficient to touch through the varnish that's typically found on pipes. So this voltage would also be good for touching through pipe. As you see it go around, where we began, we have a fairly big root gap. So the robot's travel speed is slow and the weave width is sufficient to cover all of that root gap. And as we start going along, what you'll see is the robot will move faster and faster with travel speed, and that weave width will get smaller and smaller, because as we get towards the back, that's where we have the smallest root gap. The changes that the robot is making to its travel speed and weave width will be applied to all the other passes as well. This is a 4-pass weld, and you can see how much faster the robot is going now where the root gap is very small. Here the weave width is decreased to about 0. Now we're coming back out, you see that weave width get larger and larger and see the travel speed slow down. The point of this technology, it's very simple. It's based on touch sensing, which will work even if the robot tool center point isn't perfect. Other features of the software include provisions to alter and stagger your starts and stops so that you aren't putting the starts and stops on top of each other. It's a tool that's robust and easy to maintain on the shop floor with regular shop floor personnel. Now I'd like to show you an example of a straight seam in which this technology was used. Here you can see on this piece, this is also a 4-pass weld where your root gap is very narrow at the beginning and very wide at the end. And the robot used the same technique to measure the root gap at the beginning and at the end and alter the weaving width and the travel speed to give you a constant fill across that. Looks like the volume required of that joint has changed at least 50% from beginning to end, but the robot was able to fill that and maintain the required tolerance of that weld. Typically on welds of this type, the requirement is the joint must be completely filled, -0, +3 millimeters, or they only allow about 1/8 of an inch overfill on this joint. What you can see here is that the joint has been filled completely with no overage or underage, and it's been filled the same at the beginning where the root gap was tight as it was at the end where we had a much larger root gap. So the robot was able to adaptively fill that and keep the fill consistent within the specs of this difficult joint. By using this technology, heavy plate manufacturers can apply automation to joints that perhaps weren't weldable before with conventional robotics, and do it in a way which allows a technology that the operators can keep working day to day on the factory floor.